Thank you so much for joining us today. We're really excited to share some new ideas and some new features with you all today. And so let's get started. I'm going to get back here. Cool. I want to take us back in time to 1973, 50 years ago. In 1973, Scientific American published a very interesting article in which they compared the movement of various animals. They set out to compare the locomotive efficiency. In other words, how many calories an animal burns to get from point A to point B in relation to their body mass and things like that. And what they did is they compared various animals, birds, insects, and of course us humans, and ranked them from most efficient to least efficient. What they found was the condor was the most efficient in terms of locomotive efficiency. Now, if you've never seen a condor before, it's a beautiful bird, native to California and some parts of South America, and it can fly sometimes hundreds of miles without ever flapping its wings. It has really good gliding power. Humans, on the other hand, humans who walk, came in rather unimpressively at about 1/3 down the list, which is not such a great showing for us. But the beauty of this Scientific American article is that they added one more item. In addition to all the species, they added one more item to the list, and that was man on a bicycle. Man on a bicycle blew the competition away, almost 2 times as efficient in locomotion as the condor. And I love this story because it is such a simple realization that with a little bit of tooling, a little bit of mechanical help, we can really augment our abilities by quite a lot. Now, some of you in the audience might have heard this story before. You might be thinking, where have I seen this? This story was often told by Steve Jobs in the early days of Apple. Him and the Apple team used this story as inspiration for the early Macintosh. Steve compared the story and said, humans are tool builders. We make tools like the bicycle to augment our abilities to get things done. And just as the bicycle is a tool for motor ability, for moving, computers are a tool for our mind. They augment our abilities in creativity, imagination, and productivity. In fact, Steve had this amazing phrase that he used to describe personal computers. He said, computers were a bicycle for the mind. A bicycle for the mind. I love this phrase. 10 years after this article was published in 1983, Apple released the Macintosh and unleashed the personal computing revolution. And of course, we're here now, many years later, still using Macs every day. But that was 1973. We're here in 2023, 50 years later. Computing has changed a lot. And if the folks at Scientific American ran the study again, I bet they would add one more species to the list. A species that for most of us has really only been around in the public imagination for 6 months or so. I'm talking, of course, about AI, or language models in specific. Ever since ChatGPT launched in November last year, AI and language models have captured the public imagination around the world. But more excitingly, they've captured the imagination of developers around the world. We've seen an amazing number of people integrate AI into their applications, build net new products using language models, and come up with entirely new ways of interacting with computers. Natural language interaction is finally possible in high quality. But there are limitations and there are problems. For any of you who've used ChatGPT, you know that its training data was fixed in September 2021, so it's unaware of current events. For the most part, language models like ChatGPT operate from memory, from their training. So they're not connected to current events or all the APIs out there, your own apps and websites that you use every day. Or if you work at a company, it's not connected to your company's database and your company's internal knowledge base and things like that. So that makes the use of language models kind of limited. You can write a poem, you can write an essay, you can get a great joke out of it, you might search for some things. But how do you connect language models to the external world? How do you augment the AI's abilities to perform actions on your behalf, to do more than its innate abilities offer it? If computers are a bicycle for the mind, what is a bicycle for the AI mind? So that's the question we're going to explore today, a bicycle for the AI mind. We're going to talk about GPT, the flagship set of language models that OpenAI develops, and how to integrate them with tools or external APIs and functions to power net new applications. My name is Atty. I'm an engineer at OpenAI. I'm joined by Sherwin. And together we're on the API team at OpenAI building the OpenAI API and various other developer products. Today we're going to talk about three things. First, we're going to talk about language models and their limitations. We'll do a quick introduction to how they work, what they are, develop an intuition for them, and then also learn about where they fall short. Second, we're going to talk about a brand new feature that we announced just yesterday called function calling with GPT. Function calling is how you plug OpenAI's GPT models to the external world and let it perform actions. And finally, we'll walk through three quick demos of how you might take the OpenAI models and the GPT function calling feature, integrated into your companies, your products, and your side projects as well. So let's get started. To introduce LLMs and their limitations, here's Sherwin.
Thank you, Atty. So I wanted to start by just giving a very high-level overview of LLMs, what they do, what they are, how they work, and then also talk about some of the limitations that they have right out of the box. For those of you who've been following this space for a while, this is probably information that you all know, but I just want to make sure that we're all kind of on the same page before diving into the nitty-gritty. So very high level, GPT models, including ChatGPT, GPT-4, GPT-3.5 Turbo, they're all what we call auto-regressive language models. What this means is that they are these giant AI models. They've been trained on a giant corpus of data, including much of the internet, Wikipedia, public GitHub code, other licensed material. But they're called autoregressive because all they're doing is they're synthesizing all this information. They take in a prompt, or what we might call context. They look at the prompts, and then they basically just decide, given this prompt, given this input, what should the next word be? And so it's really just predicting the next word. So for example, if an input given to GPT is the largest city in the United States is, the answer is New York City, it would think about it one word at a time, and it would say New York, and then city. Similarly, in a more conversational context, if you ask it what the distance between the Earth and the Sun is, I don't know this off the top of my head, but GPT has learned this somehow from the internet. It'll output 94 million miles. So it's thinking about it one word at a time based off of the input. Under the hood, what it's really doing is each time it's outputting a word, it's looking at a bunch of candidate words and assigning probabilities to them. And so, for example, in the original example of the largest city in the United States is, it might have a bunch of candidates. So new for like New York or New Jersey or something, lost for Los Angeles, and then some other possible examples. But you can see that it's really thinking that New York City is probably the right answer because new is assigned a probability of 95%. In this case, it generally picks the most likely outcome. So it picks new, and then it kind of moves on. After this word comes out, you now know that new is the first word. So it's kind of constrained a little bit more on what the next word is. So you can see now it's thinking New York with much higher likelihood, but it's also considering New Brunswick, New Mexico, New Delhi as well. And then once the second word has been done, this is basically a layup for the model. It basically knows that it's New York City with almost 100% probability. But it's still like kind of considering some other options with very, very low residual probability. So county, New York Metro, New York Times. But with that, it chooses city and kind of concludes its answer. For the more astute LLM folks in the audience, yeah, it's technically an oversimplification. You're not really predicting words, you're predicting tokens, like fragments of words, which are actually a more efficient way of representing the English language, mostly because fragments of words are repeated in a bunch of different words instead of the word itself. But the concept is still the same. The LLM is taking in a context, and it's probabilistically outputting a bunch of different tokens in a row. And that's it. That's really what these language models are. And with this, the crazy thing is that I think surprised a lot of us is that you can get really, really far with just predicting the next word. And so this is a graph from our GPT-4 blog post that we released in March of this year, which shows the performance of our most capable model, GPT-4, on various professional exams. And this is literally just GPT-4 predicting the next word based off of questions. You can see that it's actually performing at human or even past human performance on a lot of different exams. So the y-axis is percentile based off of amongst test takers. So it's basically at like 80th percentile, sometimes even 90th or even 100th percentile on a bunch of different exams, such as AP exams, the GREs, LSAT, USA Bio Olympiad as well. So at this point, a lot of these tests I can't even do, and so GPT-4 is well above my own ability, and this is just from predicting the next word. And so this is really cool, and you can build a lot of cool things with this. But anyone who's been playing around with LLMs for a while, you'll realize that you very quickly start running into some limitations here. And the biggest one, of course, as Atty kind of just mentioned, is the out-of-the-box LLM or GPT is really an AI that's kind of in a box. It has no access to the outside world. It doesn't know any additional information. It's kind of just there with its own memory. It kind of feels like when you're taking a test in school and it's just kind of you and the test and you're kind of coming up with things out of memory. Imagine how much better you'd do on the test if it were open note, if you could use your phone or something like that. GPT today is really just in its own box. Similarly, because of this, as engineers, we want to use GPT and kind of integrate it into our systems. And so limiting GPT and not allowing it to talk to our internal systems is very limiting for what you might want to do. Additionally, even if it does have access to these tools, because the language model is probabilistic, it's sometimes very hard to guarantee the way that the model interacts with external tools. So if you have an API or something that you want to work with, the output of the model is not guaranteed, the current model isn't guaranteed to always match the output of what the input of what an API might want, and that ends up being a problem. So for example, if I were talking to building an application and I gave this input to GPT, basically said, below is the text of a screenplay, extract some information from it and structure it in this JSON format. So I'm really just giving it a screenplay and asking it to infer a genre and a subgenre, as well as some characters from it and an age range. What I really want is I want it to output something like this, right? So it's like exactly like the JSON output, and maybe this is a screenplay about like Harry Potter romance or something. It knows that it's romance, teen romance. It sees Ron and Hermione and outputs it exactly in this JSON format. This is fantastic because I can just take this output and now I can use this and throw this into an API, and then I'm kind of like in my code and it all works. The problem is it does this maybe like 80–70% of the time. The rest of the time, it'll actually try and be extra helpful and do something like this, where it says, yeah, sure, I can do that for you, blows the information you asked for in a JSON format, which is super helpful, kind of. But if you're trying to plug this into an API, it actually won't work because there's all this random text in front and your API won't know how to parse it. And so this is obviously very disappointing, and this is not what you actually want. And so what we really wanted to do is we wanted to help break GPT out of the box, or as Atty said, give GPT basically a bicycle or another set of tools really augment its ability and have that work very seamlessly. So this brings me to the next part of our talk, which is going over what we call function calling with GPT, which is a new change to our API that we launched yesterday that makes function calling work a lot better with our GPT models in a very first-class way. So to illustrate an example of this, if you ask GPT a question like this, what's the weather like in Brooklyn today? So like, right here. If you ask it, normal GPT this, it'll basically say something like, as an AI model trained by OpenAI, I'm unable to provide real-time information, which is true because it can't actually access anything. It's in a box. How does it know what the weather is like right now? This obviously really limits its capabilities, and it's not desirable. So what we did was we updated our GPT-4 and our GPT-3.5 Turbo models, our flagship models. We took a lot of tool use and function calling data, fine-tuned our models on those, and made it really, really good at choosing whether or not to use tools. And so the end result is a new set of models that we released yesterday that can now intelligently use tools and call functions for you. And so in this particular example, when we're asking the model, what's the weather like in Brooklyn today, what I can now do is pass in this input, but also tell it about a set of functions, or in this case, one function that it has access to that it should try and call out to if it needs help. So in this case, we'll give it a function that's called getCurrentWeather. It takes in a string with the location, and then it knows that it can use this. And so in this case, in the new world, when you pass in this input, GPT will express its intent to call this getCurrentWeather function. You will then call this function yourself in your own system however you want. Let's say you get an output here that says 22 Celsius and it's sunny. We put these slides together yesterday, and so it's actually cloudy today, but it's all right. Sunny, you can pass that back to GPT. It'll synthesize this information and then return to the user saying the weather in Brooklyn is currently sunny with a temperature of 22 degrees Celsius. And so to unpack this a little bit, what's really happening is GPT is knowing about a set of functions, and it will intelligently on its own express its own intent to call one of these functions, and then you execute the call and then pass it back to GPT. So this is how you end up connecting it to the outside world. So to kind of walk through this a little bit more, what's really happening at a high level is your user is still just like a back and forth. So your user asks a question, a bunch of things happen, and then you're responding to your user. But what actually happens behind the scenes with your app is you're going through this 3-step process where you're calling out to OpenAI, then you're using your own function, and then you're calling out to OpenAI or GPT again. And so the first step, obviously, the user asks a question. In this case, it is, what's the weather like in Brooklyn today? Then the next step is, in your application, you call a model, you call OpenAI, and you tell it about the set of functions that it has access to, as well as the user input. And so very concretely, this is an example API request that actually works today. Anyone with API access can try this. So this is an example curl that uses our function calling ability. You can see that it's just normal curl to our chat completions endpoint, which is a new API endpoint that we released a couple of months ago that powers our GPT-4 and GPT-3.5 models. So you're curling this API. You're passing in a model. So in this case, you're passing in GPT-3.5 Turbo 0613, which stands for June 13th, which is the model that we released yesterday. So this is the model that's capable of doing function calling. You're also passing in a set of messages. So for those of you who might not be familiar with our chat completions format, you can pass into our model a set, basically a list of messages. That's the conversation history. So in this case, there's only one message. There's no history really. It's just a user asking what's the weather like in Brooklyn today. But you can imagine as the conversation gets longer, this might be like a 5 to 10 message list. But you're passing the messages and the model will be able to see the history and kind of react to that. And then the net new thing here is functions. So this is a new parameter you can pass in now. And what you're passing in here is you're listing the set of functions that this model should be aware of that it should have access to. So in this case, we only have one function. It's the get current weather function. And you're putting kind of like a natural language description here as well. You're saying this function gets the current weather in a particular location. You're also putting in the function signature. So you're saying it has 2 arguments. It has a location, which is a string, which is just city and state. And it's in this format, so San Francisco, space California. It also has a unit parameter as well, which is Celsius or Fahrenheit. Below the fold here, there's also another argument in here that says the only property that is required is the location. So you technically only need to pass in location. You don't need a unit here. And so you pass this function over to, you pass this request over to GPT, and GPT will then respond. In the old world, GPT would probably just respond with text. So it'll say, I can't do this because I don't have access. But in this case, what GPT actually responds with, what our API responds with, is an intent to call the weather function. And so what's really happening here is GPT is intuiting on its own that in order to figure out the current weather, I'm not able to do it on my own, but I have access to this get current weather function. So I'm going to choose to call it. And so I'm going to express an intent to call it. Additionally, what GPT did here, if you haven't really noticed, is it's constructing the argument here. So you can see it's telling you it wants to call get current weather, and it wants to call it with the argument location Brooklyn, New York. And so what it did is it saw the function signature, created a request for it, and then also kind of figured out that Brooklyn is in New York, and then kind of structured the string in this way. So it kind of figured all of this out. So with this, GPT has kind of expressed an intent to call a function now. The next step is now it's on you to figure out how you actually want to call this function. And so you have the return from the function call, get current weather with this particular argument. You can then execute it on your own. It could be local, kind of running on your own web server. It can be another API in your systems. It could be an external API. You could kind of call the weather.com API. And then let's say in this case, we call something, maybe an internal API, and it returns with this output that you saw. So 22 degrees Celsius and sunny. Given that output from the model, you start your third step in this process, which is then calling the model, calling GPT with the output of the function, and then seeing what GPT wants to do. So in this case, if you remember, I was talking about the messages. And this time, the second request you're sending to the OpenAI API, you're going to add a couple messages here. So originally, there was just one message, which was what's the weather like in Brooklyn. Now you're adding 2 new messages that represent what happened with the function call. The first one is basically a rehash of the intent. So you're basically saying the assistant or GPT wanted to call the get current weather function with this argument of Brooklyn, New York. But then you're also adding a third message, which basically says the result of the function call that you had. So this is the result of get current weather. And then you're inlining the kind of data that is output here, which is the temperature 22, unit Celsius, and description sunny. And you pass that all to GPT. At this point, then GPT takes in that input and decides, what it wants to do. At this point, the model is now smart enough to realize, hey, I've called this function, here's the output. I actually have all the info I need to actually fulfill the request. And so it'll now respond finally with text, and it'll say the weather in Brooklyn is currently sunny with a temperature of 22 degrees Celsius. And so at that point, you finally have your final output from GPT, and then that's when you kind of respond to the user. And so putting this all together, you end up getting the experience that you'd ideally like to have here, which is a user asks, what's the weather like in Brooklyn today? Your server kind of thinks a little bit, GPT expresses the intent, you do this whole 3-step process calling out to your function, and then ultimately what the user sees is the weather in Brooklyn is currently sunny with a temperature of 22 degrees Celsius. Success. And so with that, I wanted to hand it back to Atty to talk through a couple more cool demos of what you can do with function calling.
Thank you, Sherwin. So we just went through a couple of introductory topics. So first we learned about how language models work, some of their limitations in that they don't have all the training data, they're not connected to the external world, etc., that their structured output is not always parsable. And Sherwin also just walked us through the new feature, function calling, and how the API works and how you pass functions to the API and get output back and get GPT to summarize the responses in a user-facing way. So let's walk through a few demos about how you can combine all of this and apply it to your products and your applications. So let's start small. The first example we'll walk through is something that converts natural language into queries. The example we're going to do is imagine you're building a data analytics app or a business intelligence tool like Tableau or Looker. Now, some of you may be good at SQL. I certainly am not. Most often, I just want to sort of like ask the database, hey, like, who are those top users, and just have the response back. That's finally possible today. So we're going to use GPT. We're going to give it one function called SQL query. All it takes is one parameter, query, a string, that is supposed to be a valid SQL string against our database. So let's see how that works. So first, we're going to give the model a system message describing it, what it's supposed to do. So we say, you are SQL GPT and can convert natural language queries into SQL. Of course, the model needs access to our database schema. So in this case, we have two tables, users and orders. Users have a name, email, and birthday. Orders have a user ID, purchase amount, and purchase date. Now we can start querying the database with some natural language. So let's ask this question. Get me the names of the top 10 users by amount spent over the last week. Fairly normal business question, certainly not something I could write SQL for in a jiffy, but GPT can. So let's run it. So we can see that it's calling the SQL query function. It has one parameter query, and it created a nice SQL query. It's selecting the name and the sum of amount. It's joining on orders. It's getting the last 1 week of orders, ordering it by the total spent, and limiting it to 10. Seems correct and appropriate. So let's run it against our database. Great, we got some results back. Of course, this is in a JSON format and so not user renderable. Let's send this back to GPT to see what it says. Fantastic. So GPT summarized the information and said, these are the top 10 users by amount spent. This is what they spent over the last week. So global enterprises, Vantage partners, etc., etc. And this is a amazing user-readable answer. So we're going to say a quick thank you to GPT for helping us out. It's a bit cut off at the bottom, but it says thanks, and GPT says you're welcome. So fantastic. So that's a quick way to see how totally natural language, completely natural language queries were converted into structured output into a valid SQL statement that we ran against our database, got data back, summarized it back into natural language. You can certainly build data analytics apps off of this. You can build other internal tools. I know Honeycomb is here today, and they recently built a very similar tool for the Honeycomb query language, and had an amazing blog post which I enjoyed reading. So that's one example of using GPT and functions to convert natural language into queries. Let's do a second demo. This one is about calling external APIs and multiple functions together. So let's amp up the complexity level. Let's say we're here at a conference in New York and we want to find dinner reservations for tonight. We're going to call GPT with two functions. The first one is get current location. And that runs locally on device, let's say on your phone or on your browser, and gets the lat and long of where you are. And the second function here is Yelp search, which uses Yelp's API, sort of the popular restaurant review application, and you pass in the lat, long, and query. So let's run through a demo. The system message in this case is fairly simple. All it says is you're a personal assistant who is helpful at fulfilling tasks for the user, sort of puts GPT into the almost mental mode of being a helpful assistant. And I say, I'm at a conference and want to grab dinner nearby. What are some options? My company is expensing this, so we can go really fancy. So let's run that with GPT and see how it can do. So, well, of course, GPT doesn't know where we are, so it says get current location. And we're going to call the local API to get our lat and long. And so we return that. That's Brooklyn, New York, somewhere here, I think. So we'll give that back to GPT and see what it says. Great, so it has the information it needs. Now it wants to call Yelp. And it says lat, long, and query. And it says fine dining, and that's good. That's what I want. And so let's call Yelp and get some data back. Great, so we got a bunch of restaurants from Yelp's API. And I want a nice summary, of course. So let's run it again. And it says, here's some fancy dining options near your location. Lavara, Henry's End, Colony, Estuary, and great. And it says, please check their opening hours and enjoy your meal. Sounds delicious. So thank you, GPT, yet again for helping organize dinner tonight. So that's an example of using GPT and functions to call external APIs, in this case, the Yelp API, as well as to coordinate multiple functions together. So it's capable with its reasoning ability to parse user intent and do multi-step actions one after another in order to achieve the end goal. A third demo, let's ramp it up a little bit more. We talked about how GPT-4 can pass the SAT and the GRE, and if it can, it must be smarter than just calling the Yelp API or writing some SQL. So let's put it to the test. We're all engineers. We have many things to do every day, and one of the tasks that we have to do is pull request review. We have to review our coworkers' code. Now, don't tell my coworkers, but it would be awesome if GPT could help me out a little bit and make my workload a little bit lower. So we're going to do a demo of GPT that does pull request review, sort of build your own engineer. We only need one function, submit comments. It takes some code and returns a list of comments that it wants to review, so line numbers and comments. And you can imagine we can then send this out to the GitHub API or the GitLab API and post a bunch of comments. And of course, you can add more functions and make it even more powerful down the line. So let's see how that works. In this case, the prompt is a little bit long, so let's scroll up and see. We're saying, hey GPT, you're a code review bot. You look at diffs and generate code review comments on the changes. Leave all code review comments with corresponding line numbers. We're also playing around with personality here. We're saying 0 out of 10 on toxicity. We don't want that. For fun, let's try 8 out of 10 on snark. We've all known a couple of engineers who display these personalities. And then 2 out of 10 on niceness. Let's just start there. And then below here is some code that we want reviewed. It's an API method in a SaaS application that sort of changes permissions for a user. And let's run it. Let's see what GPT has to say about the code. So give me 3 review comments. And we can see it called the submit comments function, and it outputted perfectly valid JSON. And let's see what it says. It says, ooh, are we playing hide and seek now? What happened when role is not in the body? Oh, you added a little twist there. You're directly accessing the first item. Oh, casually committing to the DB session, are we? Okay, that's a little bit rude. We don't want that. So let's fix this. I'm going to exit out of this right now and go and change our prompt a little bit. Exit, great. And so behind the scenes, what I'm doing is going back to the prompt and just changing those numbers. So taking, oh man, I got toxicity, and then the next one, snark. We're taking it back to 0. We don't want that. And let's be polite. So we're going to make politeness 10 out of 10. And let's do give me 3 review comments again. And it's once again calling the function with perfectly valid JSON. And it says, oh, it's nice to see you retrieving the role value. It says your error messages are neat, nicely descriptive. I appreciate you committing to your database changes. Good work. Now, I would love somebody to review my code like this. So thank you, GPT, and I will exit. So that's a quick third demo. At its core, it's still doing the same thing. It's calling one function, given some prompt, responding to it. But what we're seeing at play is GPT's reasoning ability. GPT knows code. It's seen thousands and millions of lines of code, and it can give you good reviews. If you peel back some of this personality stuff, it's pointing out typos. It's pointing out potential error cases and edge cases. And so, we're combining here the advanced reasoning with daily tasks. It's certainly very good at coding. It's certainly very good at exams. But its intelligence applies quite broadly. And so it's really up to the creativity of developers to sort of take this and apply it to as difficult tasks as possible and sort of run the loops on that. So that's a quick wrap up of our content for today. We covered three things. First, we talked about LLMs and their limitations. We learned about how LLMs work. They're token predicting machines. We learned about their limitations. They're stuck in time. They don't always output structured output, and so on. Second, we learned about this new feature, function calling with GPT, which is an update to our API and to our models. It allows the model to, one, express intent about when it wants to call a function, and to construct valid arguments for you to then go call that function on your end. And then finally, we walked through some demos. Now, at some point, I'm going to go productionize that PR thing, and Sherwin's my manager, so don't tell him I'm doing that. Excellent. Let me bring it back to where we started. We talked about the famous Steve Jobs quote about computers being a bicycle for the mind. It's certainly been true for me. It's certainly been true for all of you. We're in the computing industry. Computers have changed our lives. Computers have augmented our abilities, our innate abilities, and given us more productivity, more imagination, more creativity. The AI and language models in ChatGPT is a baby. It's only been around for a few months, and it's up to us to sort of augment the AI's mind and give it new abilities beyond its inner reasoning abilities, connect it to tools, connect it to APIs, and make really exciting applications out of this feature. The original code is quite inspiring to me. We can never do justice to a Steve Jobs quote, so I'd love to play that video back to you right now.
I remember reading an article when I was about 12 years old, I think it might have been Scientific American, where they measured the efficiency of locomotion for all these species on planet Earth. How many kilocalories did they expend to get from point A to point B? And the condor one came in at the top of the list, surpassed everything else. And humans came in about a third of the way down the list, which was not such a great showing for the crown of creation. And but somebody there had the imagination to test the efficiency of a human riding a bicycle. Human riding a bicycle blew away the condor, all the way off the top of the list. And it made a really big impression on me that we humans are tool builders, and that we can fashion tools that amplify these inherent abilities that we have to spectacular magnitudes. And so for me, a computer has always been a bicycle of the mind, something that takes us far beyond our inherent abilities. And I think we're just at the early stages of this tool, very early stages. And we've come only a very short distance, and it's still in its formation, but already we've seen enormous changes. I think that's nothing compared to what's coming in the next 100 years.
As much as that applied to computers 50 years ago, I think the same applies to AI today. The technology is in its infancy, so we're very, very excited to see where it goes. Thank you. I think we have some time for questions. Bo is around and helping us coordinate.
Cool, thank you. I'm looking forward to doing a lot less work in the future. I've got a question about how we should cope with errors and failures and what strategies you might suggest. So taking your example where you built a SQL query, what if the question that I asked results in ChatGPT giving a syntactically correct SQL query, but semantically it's completely off? I then report back to my users something that's incorrect. It's hard to tell who's at fault here, but do you have any strategies you can suggest for coping with that?
Yeah, totally. Great question. I think the first thing is, as a society and as users of these language models, we kind of have to learn its limitations, almost sort of build antibodies around its limitations. So there is a little bit about like just knowing that, hey, the outputs might be inaccurate. I think a second part is sort of like opening the box. One thing we do, so we've integrated function calling in production with ChatGPT. We've launched a product called plugins, which basically does this. It allows ChatGPT to talk to the internet. And one thing we do is all the requests and all the responses are visible to the end user if they so choose to see them. So that sort of like helps with the information part. I personally say I think also SQL is sort of like a very broad open surface area. I think limiting it down to like well-known APIs that only will perform safe actions in your backend is a good way, and so you can always get good error messages and things like that. Yeah, but those would be my like off-the-cuff tips. But would love to like chat more as well.
Hey, great presentation. Thank you. A couple of questions. Has anybody tried this with LangChain yet? Or will it work with LangChain? I assume yes, right?
Yes, actually. LangChain, Harrison and the team launched an integration an hour after our launch.
Okay, good.
So it works. Yeah.
What about, I mean, this still exposes the leakage problem, right? Right, like the SQL example is a good example.
Yeah.
If somebody reads this and they do an SQL query against a financial database, and they're feeding it into the GPT-3.5 Turbo, basically they're leaking data, right?
I don't think I fully followed the question. Could you repeat that part?
Clearly, I mean, you guys are an expert. There's these problems where if you're using like the DaVinci 3 or different models, some of that data from the query is turning into the model itself.
Oh.
And so that example seems to me would be extremely dangerous.
I see what you mean.
So there's actually a misconception that I think we haven't cleared up very well recently, which is up until I think March or February this year, we were actually, in our terms of service for the API, we were actually, we said we reserved the right for ourselves to like train on the input data for the API. And I think that's probably what you're talking about, which is like you're passing in some SQL queries and that'll actually find its way somehow back into the model as it retrains.
There's been a couple of
In February, and I forgot the exact date, but actually as of right now, we no longer do that. So in our terms of service, we actually do not train on your data in the API. I think we haven't made this super clear, and so people are very paranoid about this. And so as of right now, it doesn't.
Is there a de facto statement on that? Because that's very important for large enterprises.
Yeah. It's so you should look it up in our terms of service.
Okay.
We don't train on it. That being said, the data is not that's being passed in is not like enterprise grade. Like we're not like isolating it like specific to your user. We're just not training it on our own data. That type of feature around like data isolation at the enterprise layer is obviously coming soon, but that specific layer of security is not there yet.
Yeah. We do not train on API data.
Hey guys, awesome presentation. Quick question, the demos that you showed were a little bit slow, so I'm wondering if, you guys support, parallelization of function calling. So like right now, everything is sequential. You get a function signature back and then you gotta, call it. But let's say ChatGPT said 3 functions should be called simultaneously. Does that work?
Yeah, great question. The demos are slow because I had to voice over and also I was doing something. There's a couple of time.sleeps in there. So ChatGPT, the API natively does not support multiple function invocation. There's no output where it says, hey, call these 3 functions, but you can hack it. The way you do it is you just define one function, which is, call multiple, and you provide a signature where the model calls multiple functions. And it totally works. At the end of the day, it's still, we're using the model's reasoning ability to output some text. Yeah.
I wanted to ask about, so in the SQL example you gave it some table to access to. Is there a way for us to just preload all of the context for any subsequent call by anybody?
I'm not 100% sure what you're talking about here. There are a couple potential solutions, and let me know if this answers your question or not. We have a feature called a system message that you can pass in, which basically sets the overall conversation context for a model. And that's just really appended in the context. And so we've been increasing the context window to something like 16,000 tokens at this point. So you can increasingly squeeze more and more things into the system message. And the model's actually trained, we didn't talk about this today, but the model is trained to be extra attentive to the system message to guide how it reacts. And so in this example, Atty had like 2 table schemas in the system message. You could foreseeably add a lot more all the way up to, kind of fill up the whole context.
Okay, so that would be how I would preload, if you will. I would just send it on every single request.
Yeah, that's the simplest. There are a couple other methods as well. I'd love to talk to you about it a little bit more afterwards. You can hook it up to an external data source, a DB or something. Fine tuning is another option as well. So there are other things too.
Thank you.
Yeah.
So I played around with integrating ChatGPT or the AI into a different software, and I had the problem that emails, which are English typically, would sometimes come in German or French when I asked it for doing some job in English, in French or German. Is this also going to happen with this function API?
Yes, unfortunately. So the model is prone to hallucination in the normal situation as well as in this situation. What we've done is basically fine-tune the model, so it's seen maybe a few 100,000 examples of how to call functions reliably. So it's much better at it than any other prompting you might do yourself. But it still makes up parameters. It might output invalid JSON. It might output other languages. And so to prevent that, we're going to do more fine-tuning. We have a couple of sort of low-level inference level techniques to improve this as well that we're exploring. And then on your end, you can do prompt engineering. And just please remind the model, do not output German, and it'll try its best.
I'm actually curious, it would be really interesting to see how, if it's gotten better at this, especially if you have a function signature and you're explicitly listing out the 5 different English enums. My guess is the newer models are probably better, but yeah, as Atty said, it won't be perfect. But I'm not 100% sure. We don't have evals for cross English French enums, unfortunately. It's probably a good one to think about, but would be curious to see if it got better with this.
And thanks for the talk. I have a question about the API's ability to figure out the intent. Is there a similar temperature parameters for the function call so that if I pass in 2 functions with similar intent, would GPT determine deterministic for each function to call, or is there any randomness of picking any which function to call if I ask it multiple times?
There is still randomness. So at the end of the day, under the hood, it's still sort of outputting token by token, choosing which function it wants to call. So lowering the temperature increases determinism, but it does not guarantee it. That said, there is a parameter in the API called function call, where if you know which function you want it to call, you can actually just specify it up front, and it will definitely call that function. Yeah.
Thanks.
Do you guys have entitlements for the function calls if we wanted to limit certain users from certain function calls, or which tables they could access in those SQL queries? Or are people still needing to implement their own?
All of that would happen on your servers because you have sort of the full context of who has access to what. All that this API provides is sort of the ability for GPT to choose which function to call and what parameters to use. But then we expect that you should treat GPT's output as any other client. So untrusted client output that you would validate on your end with permissions and stuff. Yeah.
All right, that makes sense.
I was just wondering if you could sort of perhaps elaborate on what's going on under the hood here. Is this chain of thought prompting under the hood? Is this effectively an API layer on top of those techniques?
Yeah, great question. So chain of thought prompting, for those unfamiliar, is a way to ask the model when given a task, hey, first tell me what you're going to do and then go do it. So if you say, what's the weather like in Brooklyn? It might say, I have been asked a weather request. I'm going to call the weather API, and then it goes and does that. So that's a prompt engineering technique. This is a fine tune. So with the launch of plugins a few months ago, we've collected both internal and external data, maybe a few 100,000 examples of user questions and function calls. And so this is all fine-tuned into the model, and that's where it's coming from. There's a third technique that we can use, which is called constrained sampling, where at the token sampling level, you make sure that the next token that is being predicted is one of a valid set. So in a JSON example, after a comma, it has to be a new line or something like that. You might be getting that wrong, but you get the idea of you have a grammar that you want to assign it yourself to. We don't have that yet. It's an area that we're exploring, but this is sort of the long journey from prompting to fine-tuning to more low-level stuff. This is the journey to getting GPT to output reliably structured data.
Will this work with a vector database? So the idea is I want to constrain the information based on what I fed into a vector database, so it doesn't, but it still works with the function logic?
Yes.
Brilliant.
Works exactly as it used to.
I have one last question. Are we able to use it today, or is it open to public right now?
So this is publicly available today with a caveat. So it's available on the GPT 3.5 Turbo model. So anyone here can actually access function calling with GPT 3.5 Turbo because that's generally available. It's also available on GPT-4 on the API, but unfortunately that is still behind a waitlist. And so if you are off that waitlist and you have access to GPT-4 API, you will actually be able to do this with GPT-4. It's way better at it. It is a little slower. But if you're still on the waitlist or you don't have access to GPT-4 API, you can try this out today on GPT 3.5 Turbo.
All right, everyone, cool. This is where we end our sessions. We just saw bicycle of AI mind. I'm really happy that as developers, we're now being replaced right now, actually empowering us rather than replacing us. Right? So let's give a round of applause for Sherwin.